Hi everyone, my name is Chris Harris and I'm from AlleryTutors.com, and welcome to this video on calculating relative atomic mass from Mass Spectra. So this is a really common exam question for them to ask, and you need to be able to look at a spectra and actually calculate the relative atomic mass, and they can even ask you to work out the element that this spectra can belong to as well. So we're going to show you just a method and how you can work that out, and just making sure that you know how to interpret the spectra properly. So we've got two types of spectra here, and we're going to look at this one on the left here first. As you can see, we've got percentage abundance along the left. This is basically just how much of that isotope we have, and this is the MZ, which is the mass to charge ratio, and so this tells us the different isotopes that have come through our mass spectra, or if it's a molecule, but in this case we're just looking at isotopes of the same element. So we're going to start by looking at the spectra. You can see we've got one isotope with a mass to charge ratio of 24, and we have 79% abundance. We have another one at 25, that's a 10% abundance, and we have another one at 26, and that's 11% abundance. So if this is an element, we can say that this has three isotopes, and the mass spectrometer has picked that up. So we're going to try and identify the element from this, and it's really simple. All we have to do is look at our mass to charge ratio and our abundance, and we're going to multiply that number with that number, and the same with the other isotopes as well. Add them up and divide them by the total sum of the isotopes, the total abundance. So let's make a start. So we're going to take 24 times, let's do this first one up here. So do 24 times by 79, and if we put that into our calculator, we should get 1896. And then if we do 25 times 10, that one's pretty easy, that was just 250. And then we're going to do 26, which is the mass to charge, times by 11, that's the abundance, and that's going to give us 286. Alright, okay, so if we add all them up, put them into our calculator, we should get 2432. Okay, and so this is the number that we're going to use, and we're going to divide this by 100. And the reason why we divide it by 100 is because the total abundance, 79 plus 10 plus 11, adds up to 100. Now, you've got to be really, really careful and make sure that total abundance, that you're dividing this number by the total abundance. Not sometimes they don't always add up to 100, as you'll see in this next example. So you've got to watch out for that. So in this case, it's just 24 or 2432 divided by 100, because that's our total abundance, and that's going to give us 24.32. Now, if we look in our periodic table, we should be able to find that this should actually be magnesium. So I'm going to put Mg there. And so what we've done is we've been able to identify the element for this as well. It does get a little bit complicated as well. Well, not too complicated, but it's a little bit different when we have our total abundance that doesn't add up to 100. So I'm going to show you in a perhaps tidier way than this, even neater way, for this last example here. So basically we're going to do exactly the same as what we did here. We're going to take the MZ, which is this bit at the bottom here, and we're going to multiply it by the abundance. In this case, it's not percentage abundance, these are just different numbers. It doesn't really matter as long as you divide them by the right amount. So you can see here we do 114, so I'm going to set this out like this. So 114, and we're going to multiply that by 20, and we're going to add that to 0.2 times by 21, and we're going to add that to, and we've got 11.2, and we're going to multiply that by 22. There you go, and that's just a neater way rather than doing all this. And then we're going to divide all of them by the total abundance. In this case, that's going to be 114 plus 0.2 plus 11.2. There you go, and that's the sum that we're going to put into our calculator. So we put all that into our calculator, and we should get a relative atomic mass of 20.18. And again, the eagle eye amongst you would have noticed that this element, if we look in the periodic table, is neon. That's the one that's closest. If I can form my letters properly. There we go. So that's neon. So this element is actually has 3 isotopes, as you can see, and they all come in at masses of 20, 21, and 22. Again, you can see just by looking at the average, remember this is just an average of the isotopes, so you can see that this is obviously very much weighted towards the 20 side, and that's because we've got much more of the isotope that has a mass of 20 than any of the other isotopes that's available on there. Just a final thing really is that all mass spectrometry can be used quite a lot in Mars, and it has been recently to identify to see if there's water and hence any life on Mars. So they are used quite widely, and also in the sports industry as well when detecting for illegal substances in the blood. So yeah, very useful bit of kit, and also now you know how to interpret spectra and identify an unknown element. So there we go. That's it. Bye bye.